Hi, welcome to the fifth video for the acids and bases topic for Year 11 Chemistry. In this video we're going to be kind of bringing together a lot of the stoichiometry stuff we've done before and starting to introduce some stoichiometry of solutions. And so what we're going to be looking at is something called titrations. Okay, so if you have a look in this GIF here that I've got going, this is an example of a sort of color change you might see in a titration. So what we've got here is bromothymol blue as an indicator, and it's in an acid to begin with, and then it gets to a point where all the acid is neutralized and it clicks over to a base, okay, and that's why you get the blue color. So titrations involve stoichiometry calculations, which we've done already before with number of moles equals mass over molar mass. So this time we're going to be using a slightly different triangle to do our calculations. So this triangle now, instead of being number of moles equals mass over molar mass, this is using this triangle here. Now this triangle here is easy to remember if you remember that concentration is moles per litre. So you've got to remember those units. Concentration is moles per litre. We've looked at that already in this topic when we did our calculations of H+ using pH. So we talked about concentration moles per litre. So if you remember concentration is moles per litre, it's moles over litres here. So your volume has always got to be in litres as well. Now where a lot of people often get into trouble with this is the fact that we're doing titrations, and we often do titrations using millilitres. So you have to divide by 1,000 to get it to litres in order to actually do this, okay? So this is a really important triangle. Just remember concentration moles per litre, and this goes in, I've gone into a fair bit more depth with this and show you some calculations in this video here if you want to have a look at that as well. So titrations involve generally calculating either concentration or number of moles. So I'm going to show you a couple of examples of how we do those first using that triangle. So the first one I'm going to do is calculating concentration. So using that triangle, concentration equals number of moles over volume. Right? If we've got a 10 gram solution of sodium hydroxide dissolved in 2 litres of water, what's the concentration? Well, we're going to use some of that stoichiometry before of number of moles as mass over molar mass. So we've got 10 grams dividing by the molar mass of sodium hydroxide, just from adding up all the relative atomic masses off the periodic table, and we get 0.25 moles. And then all you do is do your formula. Concentration is number of moles over volume, so it's 0.25 over 2, and we end up with a final concentration of 0.125 moles per litre. So that's pretty straightforward. Next I'm going to do is calculating volume, again just using our triangle. So concentration equals number of moles over volume. So for volume, we're going to do number of moles over concentration. So if you wanted to make a solution with concentration 1.5 moles per litre of sodium carbonate, and you had 3.5 grams, what volume of solution could you make? Okay, so again, number of moles is mass over molar mass. The mass is 3.5 grams, molar mass is 105.987 grams, so we get a number of moles of 0.033. Our volume is number of moles over concentration, so we take number of moles divided by concentration, and we get 0.022 litres, okay? Or more, we'd probably convert this into a milliliter, so we times by 1,000, and we get 22.01 millilitres. But your answer for volume will always be in litres first, so just remember that. So again, hopefully that's fairly straightforward. If you want to calculate number of moles, concentration is number of moles over volume, so what you do is number of moles is concentration times volume. So how many moles are there in 20 mils of 0.25 millimole per litre sulfuric acid? Well, you've got your concentration, you've got your volume. Notice here we've converted our volume from 20 mils into litres, so it's 0.02, just dividing by 1,000. So number of moles is C times V. Adding, multiplying them together, we get 0.0043 moles, or 4.3 by 10 to the minus 3. You have to know your scientific notation, so just remember to go through and have a look at that video which I've done on scientific notation if you need a refresher. Now, if we're going to do those calculations, we need to get the initial values, okay, those raw values. So we need to know like how many number of moles we had or what volume we used. So that's where we use titration, and we use different glassware for that. So when you go through and do a titration, you're going to use these 3 main pieces of glassware. Conical flask, which most of you probably know. Okay, but then this is a burette. Now, a burette is a graduated cylinder in a sense, which delivers a known volume. All right, it reads from the top down. So this bit here, down here, joins onto here. Normally, the ones we use in the lab are 50 mils. So it starts at 50 at the top, and then you read it down. So 50, 49, or 0 at the top, again, 0 at the top going all the way down to 50, and you can know exactly how much you add when you're doing a titration. Now we can read burettes to 2 decimal places, so when you read a burette, you might read it as something like 3.50 milliliters, okay? A pipette, sometimes called a volumetric bulb pipette because you've got this little bulb in the middle, is used to deliver an accurately known volume of solution. So this one here is a 20 ml pipette. All right, so you're going to use these in there to deliver 20.00 milliliters, and this one here is a 10 ml pipette. So again, you're delivering a known volume, and that's really important that you have some knowns, otherwise you can't do the calculations. So I've done a video here of me in the lab doing a titration, starting with preparing a standard solution, going all the way through and doing a titration. So I really want to recommend that you have a look at this video. It's on my YouTube channel. It's really good to get important techniques, all right, because titrations are all about the technique and being careful with what you're doing. Now, at this point, you might be going, well, why do I want to do titrations? Well, it's kind of the keystone, the cornerstone of analytical techniques in chemistry. So it's how we determine how much of something there is. And that's really, really important in things like the wine industry, in things like forensic science. So getting that understanding and ability to be able to perform a titration well, okay, is really important if you want to go on to those sorts of fields. And there's obviously a lot of money in the wine industry that you can make. I know a lot of people are really interested in forensic science. So you want to be able to get your titration skills down really well. All right, so please have a look at this video. I'm not going to go into all the steps and details now, but have a look at the video for how you actually perform a titration. Once you've done the titration, you'll have some values, and then you can then do your calculations. Now, a really good thing normally in the Year 12 exam for this, they break it down sort of step by step for the questions, but you always follow these same 6 steps no matter what titration you're doing. So you've got to make sure you have a correct balanced equation. You've got to write down what you know. You got to calculate the number of moles for what you know. Now that one will be the one that you've got 2 values for at least, okay? Then you calculate what we call the mole ratio. Then you calculate number of moles for what you want to know, that's the unknown, and that's just multiplying step 3 by step 4, and then you calculate your answer. Now, if this seems familiar, it's because it's exactly what we did back in the previous topic when we were doing mass calculations. So when we, for example, wanted to know how much carbon dioxide is produced from burning 3 kilograms of methane, we followed these steps. It's exactly the same. The only difference is that we're doing it now with liquids and using that C equals N over V formula instead of the N equals M over M formula. Okay? But other than that, it's the same 6 steps, so you don't actually need to learn new steps. So I'm going to show you a couple of examples. So what volume of 0.1 mole of sodium carbonate would be required to neutralize 15.6 mils of 0.5 molar hydrochloric acid? So you would do this titration, okay? Your sodium carbonate there would probably be down in your conical flask down the bottom because you've got 15.6 mils, and that's a very precise volume, so that's probably been in your burette of your 0.5 molar hydrochloric acid. So first step, balanced equation. You've got to get this right. I keep saying to my students, you've got to know how to write your formulas and how to balance your equations. That's key, because if you get that wrong, you get the mole ratio wrong, you get everything wrong in this, all right? So you've got to be able to balance and write formulas. So we've got our balanced equation here for sodium carbonate and hydrochloric acid to give us sodium chloride, water, and carbon dioxide. Here's our concentration. I've tried to color code so you can see where we follow everything through. So this is up the top, 0.5 moles per liter of hydrochloric acid. Volume of hydrochloric acid is 0.156. So just converting that milliliters into liters again, dividing by 1,000. And here's our concentration of sodium carbonate. So we're writing down what we know. And the reason we do that is just to extract the information out of the question, because sometimes it can get lost if there's a lot of words in there. So pull that out, and you can then have a look and see, all right, we've got 2 things for hydrochloric acid, 2 values, only 1 for sodium carbonate. So this hydrochloric acid is unknown. So what can we do? Calculate number of moles. Number of moles equals concentration times volume, so it's 0.5 times 0.0156. So here's our number of moles of hydrochloric acid, okay? That's step 3. Step 4 is mole ratio. So our unknown is sodium carbonate up here. So there's a 1 in front of it. Our known is the hydrochloric acid. There's a 2. So it's a 1 over 2 for the mole ratio. Then you do step 5, number of moles of your unknown. Now remember, that's just step 3 by step 4. So it's the mole ratio, 1 over 2, times by the value we had up here from step 3. and we get 0.0039 moles. Now the really important thing to know here, and I've written here, is don't round off on your calculator. So if you're good, if you want to get really good at stoichiometry calculations, do this on your calculator and just follow it step by step by step. Don't round off. Just use the answer before that's on the calculator and keep going. Then what you're going to do is, for your final one, we're asking what volume. So V equals N over C from that triangle. So it's here, 0.0039 moles divided by 0.1, which is what we were given, and we get 0.039 litres or 39 millilitres of sodium carbonate. So it's exactly the same as what we're doing with the mass and mass calculations for the previous topic, but we're just doing it with volume this time, okay? 6 steps are really easy to learn and go through. Stick to the steps and you'll be fine. So another example here, I'm not going to go through this one in the same depth as before. I'm just going to leave it on the screen for a second if you want to pause it and have a look through. But you'll see it's exactly the same 6 steps. So all I've literally done for this is copy one slide to the next, just change some values. But again, going through and calculating this time concentration instead of volume. So the only difference is in the final step, we're doing C equals N over V instead of V equals N over C, which is what we did in the last one. But we end up with a value here of 0.188 moles per litre. So there's no substitute for practicing. This is what I said in the last topic when we were looking at doing these sorts of things. Do as many questions as you can. Practice them, have a look at them. So I've got 2 separate videos here around titration calculations. The first one here, titration calculations, this one starts with a little bit simpler, and then we get into some more complex ones here for titration calculations number 2. Really want to recommend that you go through those and do as much as you can. If you have a look on my website, I've actually got a playlist as well for stoichiometry calculations and titration calculations. Lots of different videos, short videos with examples. Have a look at those as well. Alright, that's all for this topic we've been looking at for acids and bases. Hopefully you've learned a bit. Hopefully I've explained it really well. If there's anything you're unsure about, please ask me. If you've got any thing out of this topic or any of the other topics that you'd like me to make a video on, please let me know as well. As always, thanks for watching. If you haven't hit subscribe please. That'd help me out a lot. And I'll see you in the next episode. Thanks, guys.